Hello, you're welcome to today's class. Today's topic is relative atomic mass, relative molecular mass, and moles. Although we said something about moles and we solved some questions on it in the previous lesson, but in this particular lesson, we'll be taking more questions on this thing. But then before we go on to solving, I would like to lay a foundation that's based on those listed out topics on what we're about to solve. So let's start with defining what all these things are, and when we are done defining it, we then look for the relationships between them, and then we'll take some questions, and I hope after that we'll have a better understanding of this topic. But then it is still necessary that before now you must have read a chapter in your chemistry textbook or chapters in your chemistry textbook that has to do with this thing, so you have a previous thorough knowledge of what we're about to solve. So the first thing that I would like us to know is the definitions, as I said earlier on. So let's start by writing down the definitions, and then we can still continue. So what are atoms, or what is an atom? I think that is a good question. So let me put down the definition of atom here. From this definition, an atom is the smallest particle of an element which can take part in a chemical reaction. And now I believe we know what elements are. We don't need to go into that. We know examples of elements: sodium, magnesium, calcium. Those are elements. Oxygen, hydrogen, carbon, they are elements. So an atom is the smallest particle of an element which can take part in a chemical reaction. Now the next one we have here, it's molecules. So what are molecules, or what is a molecule? That should be the next question. So let me write it down also. So here I have that a molecule is the smallest particle of a substance that can normally exist alone and still retain the chemical properties of that substance, be it an element or a compound. So a molecule of a substance retains the chemical properties of that substance. For example, if you have a jar of salt, and then you pick out a particle, I'm just giving an example, a particle of that salt, if you subject it to analysis, you still discover that's for common salt, that tiny particle is made up of two major atoms, and that is sodium and chlorine, no matter how small it is. So A molecule is the smallest particle of a substance that can normally exist alone and still retain the chemical properties of that substance, be it an element or a compound. Now you might have a question, that's if you don't know what a compound is before now, the next question of mine should be, what then is a compound? Already we know that. Okay, let me still restate it, that a compound is a substance which contains two or more elements chemically combined together. From that, the illustration I gave about salt, if you get a particle of salt, that salt, common salt, it's a compound. It contains two atoms chemically bound together, and they are sodium and chlorine. So let me put it down. A compound is a substance So, believe now we know what an atom is, what a molecule is, and then also what a compound is. So, the next term we want to define is relative atomic mass. So, what does this term imply? Relative atomic mass. As R-A-M. Okay. The relative atomic mass of an element is the number of times the average mass of one atom of that element is heavier than 1/12 the mass of one atom of carbon 12. You can go back to your chemistry textbooks and still check the definition. So let me still restate it, that the relative atomic mass of an element is the number of times the average mass of one atom of that element is heavier than 1/12 the mass of one atom of carbon 12. So we know that elements are made up of atoms. We have atoms, okay, sodium atoms. The element sodium has, if you get this sodium, we have atoms of sodium, atoms of calcium, and so each of those atoms have a particular mass. Now, when we say relative, that means from the definition I gave, we begin to compare the mass of an atom of that element with the mass of, that's 1/12 of the mass of one atom of carbon 12. So let me still put down the definition. Now, this is a written definition of relative atomic mass. So it can be represented as, let's say, mass of one atom of an element all over 1/12 That's 1 atom of carbon 12. So if the mass is in grams and that of this one in grams, you discover that grams will cancel grams. And what I want to say here is just that relative atomic mass, it has no unit. There is no unit, there is no dimension, because you divide we are comparing two masses. Okay, this mass all over the other mass, so the units will cancel. For example, that's G over G cancel. So relative atomic mass has no unit. The next we have here also is relative molecular mass. This is where I am now. We have discussed atoms, molecules, relative atomic mass. Now the next here is relative molecular mass. So what then is the relative molecular mass? From our definition of a molecule, we say that it's the smallest particle of a substance that can normally exist alone and still retain the chemical property of that substance, be it an element or a compound. So we can say a molecule of an element or a molecule of a compound. So now, the next is relative molecular mass. The relative molecular mass of an element or a compound is the number of times the average mass of one molecule of it is heavier than 1/12 the mass of one atom of carbon 12. It's similar to relative atomic mass, just that when we are discussing relative molecular mass, we're discussing molecules and no longer atoms. So let me put it down. So this is the definition of the relative molecular mass. As you can see here, I gave a representation of it, that's RMM. So just as we said in relative atomic mass, the relative molecular mass, it has no unit because we are comparing two masses. So because of that, there is no unit. It is without a unit. So the relative molecular mass is the sum of the relative atomic masses of all the atoms in one molecule of that substance. I hope we get that. I'm just trying to add more to this definition. It says it is the sum of the relative atomic masses of all the atoms in one molecule of that substance. So because we know a molecule contains many atoms, okay, either of an element or a compound. So when you add the relative atomic mass of all the atoms in that molecule, then you obtain the relative molecular mass. For example, let's say we have 50 balls in a container, then each ball weighs 12 kg. if you add the weight of each of those balls, that's when you will get, and add it to, okay, if you add the weight of all those balls, then you get the total weight of all the balls in that jar. Let's say all the balls in that jar make a molecule. So when you add the individual weights, which in this case I'm trying to say are the atomic weight, if you add all together, then you will obtain the molecular weight. I hope we get the explanation. So let me still repeat what I said before the illustration. I said that the relative molecular mass is the sum of the relative atomic masses of all the atoms in 1 mole of that substance. So having gone through relative molecular mass, the next one we have here is the formula mass. If you can look carefully, you see what I'm saying. We'll have the formula mass, then we'll have moles, molar mass before we go into solving equations. So what then is the formula mass? Every element, okay, let's say every compound has a formula. Every element also has a particular representation, that's a formula. For example, sodium, that's Na, calcium, C, capital letter C, small letter A. Then if we're talking about salt, NaCl, will have a formula representing the particular chemical compound. So because of that, there's what we call a formula mass. So it's just the mass of the formula. That's if we are talking about an element, just the mass of the element. Or then if we are trying to discuss a compound, then the mass of the compound. So the formula mass refers to the relative mass of a molecule, ion, radical, electron, or any other specified group. Also, it has no unit. So let me put down the definition. So having written down the definition of the formula mass, the next we are to discuss now is the mole. The mole. So what's mole all about? Already we discussed molecule, discussed atoms, relative molecular mass, and the rest. So what's the mole all about? 1 mole of a substance is the amount containing as many elementary entities as the number of atoms in exactly 12 grams of carbon. 12. Let me put down the definition. So a substance, the amount of a substance containing as many elementary entities as the number of atoms in exactly 12 grams of carbon 12. That is the mole. That's 1 mole of that substance. And by elementary entities, we are referring to atoms or molecules or ions or electrons. And it's good to note that the unit of mole is equals to mole. So in chemistry, this particular quantity, that's the mole, is very, very important. Okay, so for example, if we have this as calcium triiosocarbonate, what these three represent, what it means is that we have 3 moles of calcium triiosocarbonate. Also, if we have this, what it means is that we have 1 mole of oxygen gas, or you can still say oxygen molecule. Yes, oxygen gas or oxygen molecule. Now this is 1 mole of oxygen atom. Here we have 3 moles of oxygen molecules. So that's just the mole. So if you look carefully, this definition is perfect. At this point, I will refer you to the first video where we solve questions on number of atoms using Avogadro's number, that is 6.022 times 10 raised to the power 23. Because we know that 1 mole of substance, okay, the Avogadro's number is equals to that, and then 1 mole of a substance contains exactly that number of atoms or that number of molecules. So having discussed the mole, that which is remaining is just molar mass. Yeah, if you look carefully here, this is where we are now. Molar mass. So we'll ask ourselves, what then is the molar mass? The molar mass of a substance is the mass of 1 mole of the substance represented in grams. Just the way we have a mole of a substance. Okay? So the mass of 1 mole, that is the molar mass. Or we can still say that the molar mass is the formula mass expressed in grams. I hope we are following. Let me go again. I said that the molar mass of a substance is the mass of 1 mole of the substance represented in grams. Or we can still say that the molar mass of a substance is the formula mass expressed in grams. So with that being said already, I believe we have an understanding of what the molar mass is. And unit of molar mass, let me put it down here. So because we're discussing 1 mole, that's the mass of 1 mole. Although in some questions you might be asked to just leave it in grams and forget about putting per mole. So if you follow thus far, that means you have the basic understanding needed to go into question solving. So now is the time to solve questions. The first question we have for today is this. It's written here, boldly says, calculate the relative molecular mass of sodium triazonitrate 5. And already we have been given the relative atomic masses of the elements involved. So how do we go on to solve this? Let's see. We'll have and take note of what you are asked to find. I'd like to list out one of the basic steps I take in solving questions. Whenever I'm given a question to solve, one of the things I do is to take note of what I been given. By that I mean the values or compounds or elements mentioned in the equation. Then the next thing I do is to take note of what I am asked to obtain. And from this question, you can see that I am asked to obtain the relative molecular mass of sodium triazonitrate. And so if I have that, now the last thing I do is, what is the connection So what is the connection between point 1? Let me call this point 1, point 2, point 3. What's the connection between point 1 and 2? So if I can identify the connection, then I can begin to solve. So from this point, we can see already that we have been given the formula of the compound, that's sodium triazonitrate, and also we have been given the relative atomic masses of the elements involved. So what to do is just to say, okay, I'm still solving here. So from this formula, you discover that we have one atom of sodium, one atom of nitrogen, and then 3 atoms of oxygen. That's sodium, 1 atom, and 1 atom. Nitrogen, 1 atom. Oxygen, 3 atoms. So with that, we can solve properly now. So here, what we just put down is this. This 23 is for sodium. The 14 is for nitrogen. And then remember, for oxygen, we have 3 atoms. 1 atom of oxygen is equals to 16. That's the relative atomic mass. But then for 3 atoms, we have to do 3 times 16. So 3 times 16 plus 14 plus 23. That is 85. So what we have is 85. So you can say that the formula mass or the relative molecular mass of sodium triazonitrate 5 is equals to 85. Note, no unit was specified. We don't need a unit. The relative molecular mass, relative atomic mass, or the formula mass has no unit. So let's take the second question. Here we have the second question. Second question says, calculate the molar mass of this acid, that's tetraoxosulfate 6 acid. Remember from the previous question we solved, I listed out 3 steps. You take note of what you have been given. That we have been given the relative atomic masses of each of the elements and also the formula of the compound. Now you take note of what you are asked to find. We are asked to find the molar mass, and then the next thing you do is to say what is the connection between what you have been given and what you are asked to find. If you identify the connection, you can work your way towards the answer. So once again, we try to split them into the atoms. Hydrogen. For hydrogen, we have how many atoms? 2 atoms of hydrogen. Then for oxygen here, oxygen, we have 4 atoms. Then for sulfur, we have only 1 atom of sulfur. So to obtain the molar mass of this, as the mass of 1 mole of these things, what do I have to say? And I'll write out the formula again. So mass of 2 atoms of hydrogen, mass of 1 atom of sulfur, and then the mass of 4 atoms of oxygen. So we have 1, that's 2 times 1. Let me make it bold. 2 times 1 plus 32 plus 4 times 16. That will give me 98. And remember, what we're asked to find is the mass of 1 mole. So that's 98 grams per mole. What this means is that 1 mole of this substance, of this acid, contains 98 grams. Now, at this point, we're ready to go to the next question. And the next question, that's the question 3. Still similar to what we have been solving. The step is still the same. So if you can still remember the steps, you can go on solving a lot of questions speedily and readily. So let's take the next one. Question 3. Question 3 says, calculate the mass, the molar mass of magnesium tetraoxosulfate 6 heptahydrate crystals in grams. Note, in grams. So if you can still remember the 3 basic steps I listed, that take note of what has been given. Here we're given the name of the compound and the formula. That's the chemical formula of the compound. Okay, that's 1. 2, what are we asked to find? We're asked to find the molar mass in grams. Molar mass in grams. And then the next thing is, what is the connection between both? Between what you have been given and what you are asked to find. Now, the connection starts from listing out the elements involved and then the number of atoms, okay, so of each of that element in this chemical compound. Remember the chemical compound. It's hydrated salt, that's this. So the elements, we have magnesium, then we have sulfur, so we have oxygen, then we have hydrogen. So how many atoms of magnesium are in this compound? We have one atom. How many atoms of sulfur? We have one atom. How many atoms of oxygen? Here we have 4 plus 1, and then that's 5. 5 atoms. How many atoms of hydrogen? We have 2. Okay, 2 atoms. But if you take note, you discover that this is 7. So that means we actually have 14. That's 7 moles of water now. That means we actually have 14 atoms of hydrogen here, and then we'll have 7 atoms of oxygen here plus 4 atoms of oxygen here. Okay, so some persons can decide to actually get all these atoms here correctly, or we just get the total number of, that's the total mass of water molecule and add to this. But let's continue with the approach we are using. So 1 atom of magnesium, 1 atom of sulfur, 4 atoms of oxygen here plus 7 atoms of oxygen here. That's 7 plus 4, which will give us 11. So actually what we have is 11 atoms of oxygen. Then the next is hydrogen. We have 2 atoms of hydrogen times 7, that's 14. So what we have actually is 14 atoms of hydrogen. Then the next thing we need to obtain is then the relative atomic masses of each of those things concerned, each of the elements concerned. And then for hydrogen, although it was not given to us, but at this point I would like to say it's actually necessary that you have at least the relative atomic masses of the first 30 elements. That's hydrogen, helium, lithium, beryllium, boron, carbon. From there down, way down to the 30, that's the first 30 elements. That's because they are the ones that occurs mostly in our exam questions. So it's very necessary that you have the relative atomic masses of each of these elements in your head, so you can solve better even when you are not given the values. So magnesium is equals to 24. Sulfur, that's the relative, I'm listing out now the relative atomic masses. Magnesium is 24, sulfur has 32, oxygen 16, hydrogen 1. So let's come back to this again. So when we have this, what we then do is just to begin to add. So for magnesium 24 plus, for sulfur we have 32 plus oxygen 4 times 18 plus for hydrogen we have 2 times 1 plus 16, everything in this bracket times 7. Or we can still choose to multiply at this point, just 1 times 24 plus 1 times 32 plus 11 times 16 plus 14 times 1. So let's compare and see which approach is faster. And at this point, all we need to do is just to begin to add what we have. So we have 7 times 18, that's 7 times 18, 2 times 1 is 2, plus 16, 18, 7 times 18 plus 4 times 18, 4 times 16 rather, plus 32 plus 24. That will give us 246 grams. Remember, we're asked to find in grams. Now, if we want to use this approach, all we have is, for this one, we have 1 times 24, 1 times 32, 11 times 16, 14 times 1. So that's 24 plus 32 plus 11 times, okay, that's equals to 11 times 16, 176, 14. So when we add all of them together, we'll have 24 plus 32 plus 176 plus 14. And that will still give us 246 grams. So if you want to use this, list this out, write it out this way, or from here just calculate the total number of atoms of each element, multiply by the relative atomic masses, add quickly. That still makes sense. So let's take the fourth question. So here's question 4. Question 4 is still simple. Here it says calculate the molar mass of calcium hydroxide. Calculate the molar mass of calcium hydroxide. What has been given? That's the name of the compound, calcium hydroxide. What are we asked to find? To find the molar mass. What is the connection between both? Okay, from the given name of the compound, we need to obtain the chemical formula of this compound. So what's the formula for calcium hydroxide? Calcium hydroxide, that's calcium. That's the right chemical formula for this. So when we obtain this, is the formula. So the next thing we go to is, okay, then the next thing is the number of atoms of each of the elements that make it up. So for the elements we have calcium. Have how many atoms of calcium? We have 1 atom of calcium, 1 atom. Hydrogen, but here we have 2. What this 2 means that we have these hydroxide ions. Look at this hydroxide ion, 2 moles of the hydroxide ion in this particular compound, and that means we have 2 atoms of hydrogen and 2 atoms of oxygen. So here we have 2 atoms for the hydrogen and then 2 atoms for the oxygen. So the next thing is, what then is the relative atomic mass of each of the elements? We also need to obtain the relative atomic mass, and that's why I said it's necessary we have in our head the relative atomic masses of the first 30 elements. So here we have for calcium, that's 40, for hydrogen 1, oxygen 16. So let me still solve the way I did it earlier on. I can still say that's for these 2. Then here we have 16 for the oxygen plus 1 for the hydrogen. So that's going to be 40 plus 2. That's 2 times 17. So 2 times 17 will give us 34 plus 40. That's Hence, we're asked to obtain the molar mass. So this is going to be gram per mole. It means that 1 mole of this substance contains 74 grams. That it weighs 74 grams, 1 mole of it. Or we can still use this approach here by just saying 1 times 40 plus, 1 times, that's 2 rather, 2 times 1, 2 times 16, and this is going to give us 40 plus 2 plus 32. So when we add both, that 40 plus 2 plus 32 quickly, we still obtain 74 grams per mole. It means that 1 mole of this substance contains exactly it weighs exactly 74 grams. And we'll take another question. That's question 5. Here is our question 5. Question 5 says, what is the mass of 3 moles of oxygen gas? What is the mass of 3 moles of oxygen gas? So let's still go back to the 3 basic steps I gave us. First step, take note of what is given. We're given the compound, or the compound involved. We have oxygen gas O2. Then what also has been given to us? 3 moles. So it's clear to us that it is 3 moles of this compound we are considering. The next thing that has been given is also the relative atomic mass of oxygen. So what's step 2? Step 2 is, what am I asked to find? And that is, let me just list out the step here. First step, what has been given? So from this question we have name of compound, that's name of compound, which is oxygen. Also we have been given of moles of compound. Here that's 3. So the next thing that has been given to us is the relative atomic mass of the element. That's 16. So the second step is, what asks to calculate. So here you can see already that I'm asked to obtain the mass. That's mass of 3 moles of oxygen gas. So then the last step, step 3, it's let me say here, please, don't go on listing out step by step this way while solving a theory question in the exam hall. I'm just trying to use this to teach. Okay, so don't go on solving it, listing it out this way. No, I'm just trying to use this to make us understand better. What we need to do now in the solution is, we need to obtain what is the mass of 1 mole of oxygen gas. We see that a mole of oxygen gas is it means we have 2 atoms, and so that is going to be equals to 2 times 16, which is 32. So that means that mass of 1 mole of oxygen gas, it's 32. That's the molar mass of oxygen gas. Therefore, we then ask ourselves, what then is the mass of 3 moles? So we just cross multiply. That's trying to solve for it. We usually use this thing. Just say 3. That's just 3 here. Times 32 all over 1. That's going to give me you can choose to use this or also go by solving with a formula, and that's faster. I'll be explaining and listing out the formulas, but also in the previous video, that's the video on Avogadro's number, molar volume, and mole, I wrote down this formula. That is a basic formula used in solving this kind of question. That's number of moles is equals to the reacting mass all over molar mass. So from here we know we're given number of moles as 3, reacting mass is unknown, and the molar mass of oxygen gas, that's 1 mole of this gas weighs 32. That's 32. And when we make this x, that's the reacting mass. S is equals to reacting mass. When we make x subject of formula, we'll discover that x, which is equals to reacting mass, is equal to 32 times 3. 32 times 3, and that's equals to 96 grams. Okay, sorry. That means 1 mole of oxygen gas weighs 32 grams, and therefore 3 moles of oxygen gas weighs what? 96 grams. Okay, there are relationships between mole and some other parameter, let's say physical quantities or parameters. For example, in that formula I gave us earlier, I said that number of moles as the reacting mass over the molar mass. That is one. Now, from this, you can see that there's a relationship between moles and mass and also molar mass, and that is this. Also, there is another formula that's a formula that best illustrates the relationship between moles and then the volume of a gas, or the molar volume of a gas. That's this. This particular formula or this relationship came out of this statement that that 1 mole of a gas at standard temperature and pressure, that is STP, is equals to 22.4 dm cube. So it's out of that this relationship was derived. Another, okay, because of that, you see that you can actually merge this one, that's equation 1. You can actually merge equation 1 and equation 2 to obtain another formula, and that is this, that reacting mass and that becomes equation 3. Now also there is a relationship. Now here we're talking about volume of a gas. What of when it's a liquid? So whenever it's a liquid, that means we are discussing a solution. Also, a gas has volume, a liquid also has volume. Both are fluids. So when it's a liquid, there's also a relationship between moles and then the volume of a liquid, and that is found in, that's when you're discussing molarity of a solution or solubility. Although that's not our main focus today, but I'd like to list out some formulas relating them, and we'll also take, I think, a question on that later on. But then subsequently we'll make a video on this particular subtopic that I mentioned now, that's molarity solubility. You can just watch out for our videos later. So we have that molarity. Yes, molarity is equals to moles of solute volume in dm cube. It's good you take note of this, volume in dm cube. So molarity itself is equals to moles of solute all over volume in dm cube. And already we know the number of moles is this, that's the reacting mass or mass of the solute over the molar mass. And then this is in dm cube. I would like to say that from experience, at certain point our volumes are given to us in cm cube, owing to the fact that in the laboratory the measuring cylinders are calibrated in centimeter cube. So because of that, it's necessary to convert the volume you obtain, that's from cm cube to dm cube, for it to fit into molarity. So just stick, let me give you the next formula to consider. Oh, it's a bit close. There's a mass of solute so I still have some other equation, but we've lifted out 5 now. Yes, 4, and then this is the 5th. So here we have that molarity is equals to mass of solute, that's the reacting mass, all over the molar mass, times 1000 cm cube of solvent all over volume of solvent, that's equals to molarity. This same formula, that's this, because mass over molar mass will give you moles, and then volume, if the volume was in cm cube, we know that 1000 cm cube is equals to 1 dm cube. So if we convert the volume we obtain, given in the equation, if it is in cm cube to dm cube, we will need this relationship, and that replaces this. For this one, I already have stated the relationship, so let me highlight them and here. Okay, also we have another one here. Okay, I'm just trying to So we have actually five already listed or already given equations that we'll be needing to solve. But then before we continue, I also like to give us another equation that still it's helpful in solving questions that have to do with modes, and that is this particular equation. Okay, that's that mass concentration all over molar mass is equals to molarity. Okay, and then also we know, okay, let me say, not really we know, I know that mass concentration is equals to mass in grams all over volume in dm cube. These equations will be revisited when we start solving questions on molarity and solubility. That's, as I said earlier, it is good to take note of these questions. Just take note of them, put it down, they'll be revisited. So here we have how many equations? We have 1, 2, 3, 4, 5 equations. No, so this is the sixth one, and then this is the seventh equation. It's using an equation to solve. For me, I consider it to be faster. Okay, it's quite faster. So let's take the remaining questions. They'll have how many moles of molecules are contained in 25.4 grams of glucose? How many moles of molecules are contained in 25.4 grams of glucose? Now, if we want to go on solving this, I usually do say let's remember the basic steps. Start from what you have been given, what you're expected to find, and then ask for the connections between both. Now, we have already been given the mass of glucose, that will be given the mass and then the compound itself, and also what are we expected to find? Moles. That's the number of moles of glucose. So basic thing you need to do is to obtain the molar mass of this compound. And how do I go about that? To obtain molar mass of compound. Here we have the compound given as this. So from this, it's obvious that we have 6 atoms of carbon, 12 atoms of hydrogen, and then 6 atoms of oxygen. Now the next thing we need to also obtain is the relative atomic masses of each of them. For carbon, the relative atomic mass of carbon is 12, so we have 12 times 6. For hydrogen, we have that the relative atomic mass of hydrogen is 1, therefore we have 12 times 1. Then for oxygen, that of oxygen is 16, so we have 16 times 6. So when we add every of this together, then we obtain the molar mass of this compound. So let's do that. 20 as 12 times 6 plus 12 plus 16 times 6. That's a 12 times 6. That's 180. So we have 180 gram per mole. What this means is that 1 mole of glucose, the 1 mole of glucose contains or weighs 180 grams. Therefore, how many moles of glucose will weigh 25.4 grams? That is this value given to us. So what we'll have is that x moles, that's the unknown number of moles, x moles is equals to therefore we'll have from here you can already see that the answer to this is 0.14 moles. What this means is that 1 mole of glucose weighs 180 grams, and also that 0.14 moles of glucose weighs 25.4 grams. Now, if you want to use one of those formula, okay, the formula I gave to you, if you can still recall, formula 1, it says number of moles all over reacting mass over molar, number of moles is equals to reacting mass all over molar mass. And if I want to use that, what I'm going to do here is just to come to this point and say that's we can term here method 2, or using formula. So if I want to use formula, all I need to do is to state my formula. Already I've obtained the molar mass. So what I'll have is just to put in 25.4 all over 180. And when I compute that to give me 0.14 moles. So why am I including the formula? Many persons don't really know how to match this relationship, although it's quite simple. So, but if you really understand how best to work with formulas, you can always use this one. And mostly for our objective questions, that's for those writing objective exams that have objective questions like JAMB, objective in WAEC, or some other exams, you can quickly use this since steps and the rest are not being marked. All the focus is just on obtaining the answer to the question. The next question we're going to solve is question 7. As you can see, question 7 reads, how many grams of copper are in 2.55 mole of copper? Now, I have been repeating these steps. You have to, number 1, take note of what has been given. The element in equation is copper, and we have been given 2.55 mole of copper. The next thing you need to watch out for, that's step 2, is what am I asked to find? Here we need the mass or the weight of this 2.55 mole of copper. What is the weight? That's how many grams of copper are in 2.55 mole. And the next step is to try to ask yourself, what is the connection between the both of them? So once you've reasoned along these 3 steps, you can be able to solve this question correctly. So let me start again. Now, usually, if you have been following in question 6, I solved it with a certain approach on this side, and then another approach that's using formula on this particular side. So let me go again. The element is copper. So what is the relative atomic mass of copper? We know that one atom of copper weighs 63.5, and that also is the molar mass of copper. From our definition of molar mass, if we go back to it, the mass of 1 mole of copper, that's the molar mass of copper. 1 mole of copper, that's CU, weighs 63.5, and that's the molar mass, or the relative. Okay, this is the molar mass of copper. We know that the molar mass has units, but then the relative atomic mass or the formula mass has no unit. So the molar mass of copper is 63.5, 1 mole. Now when we have 2.55 mole of copper, it is going to weigh what? So that means we are going to equal to, here we're going to put down the answer to that solving. That's 2.55 times 63.5, and that will give us 161.93, which is approximately 162 grams. That means that 2.55 mole of copper will weigh this. Or we can decide to use just the formula. If we want to just use formula, we know that number of moles is equals to the reacting mass all over the molar mass. We know that the molar mass of copper is equals to 63.5. I've been given the number of moles as 2.55. So if I just substitute these values, that means here we'll have 2.55 is equals to the mass all over 63.5. So when I make the mass the subject of the formula, I will have that mass is equals to 2.55 times 63.5, which is equals to 162 grams. So we're going to the next question. The next question here is question 8. And here question 8 reads, how many moles of nitrogen atoms are contained in 9.34 grams of nitrogen? How many moles of nitrogen atoms are contained in 9.34 grams of nitrogen? So still go ahead to solve this. Okay. Now we need to know the molar mass of nitrogen atom. So we know that molar mass of nitrogen is equals to 14 grams per mole. It means that 1 mole of nitrogen weighs 14 grams. So we know that 1 mole of nitrogen weighs 14 grams. Yeah, by this I mean weighs. Trying to use it to represent that. Therefore, how many moles, as I'm using x moles now, will weigh 9.34 grams? So if I want to do that, I have to multiply this with this and divide by 14. This to this, divide by 14. So I will have 9.34 times 1 all over 14. Therefore, x moles is equals to 9.34 divided by 14. That is 0.667, which is approximately 0.67 moles. So what this implies is that that's 0.67 moles of nitrogen weighs exactly 9.34 grams, or that 9.34 grams of nitrogen, is going to give us 0.67 moles of nitrogen. Let me see use the formula method here. That's just by putting the formula. Already by now I believe we are used to this formula. Reacting mass all over molar mass. The molar mass is 14. We'll actually get the number of moles. So number of moles is equals to 9.34 all over 14, and that is equals to 0.667 moles, which is approximately 0.67 moles. From this, I believe it's clear to us that questions in this that has to do with reacting mass moles, you discover that either you are asked to find the moles and then you are given the reacting mass, and then by the reason of the element or compound mentioned, you can actually find the molar mass, or you'll be given the reacting mass and then you're asked to find the mole, or you'll be given the number of moles and then the mass of that element or compound, and you are asked to obtain the molar mass. So that is how the formula is being manipulated and equations can be formed. You can be given, let me repeat myself, you can be given the number of moles and you are asked to find the reacting mass, and from you can infer the molar mass from the compound or element mentioned, or you can be given the reacting mass and the molar mass and you're asked to find the number of moles, or you'll be given the number of moles. Let's say you'll be given the number of moles and the reacting mass and you're asked to find the molar mass. So it's either this is missing, or this is missing, or this is missing. Those are the categories questions can actually arise from. So let's go to the next question. Next question is question 9. Question 9 states, how many moles of sulfur atoms are contained in 80.3 grams of sulfur? How many moles are contained in 80.3? So as you can see, we have been given the reacting mass, and then also we've been given the elements. Therefore, we can, from previous knowledge, you should know the relative atomic mass or the molar mass of sulfur before now, and you're asked to find just the mole. So this is going to be a fast one. So 1 mole of sulfur atom weighs 32 grams. That means the molar mass of sulfur means molar mass okay. Now the question is then, how many moles of sulfur weighs 80.3 grams? So if 1 mole weighs 32, how many moles will weigh 80.3? So what we have to do is this 80.3 times this divided by 32. Therefore we have 80.3 times 1 all over 32. That is equals to 32 as 2.509, which is approximately 2.51 moles. So 2.51 moles of sulfur will weigh 80.3 grams or contains 80.3 grams of sulfur. Let me solve with the method 2 here. I'll just call the method 2. That's by simply using formula. Molar mass of sulfur, already we know it's equals to 32 grams per mole. We have this formula, number of moles being equal to reacting mass all over molar mass. Therefore, we'll just substitute what we have. We have the mass as 80.3 all over 32 grams per mole. Hence, we'll have 2.51 moles. So you see, solving equations on relative atomic mass, relative molecular mass, modes, they're not as difficult as they appear to be. Now the next question is, what is the molar mass of a substance if 0.4 mole of the substance has a mass of 2.50 grams? We've been given the mole, we've been given the mass of the substance. We are asked to find the molar mass. If you can look back to what I said then, I mentioned that the changes from that formula can be given the reacting mass and the molar mass, and you're asked to find the mole, or you'll be given the mole and then the reacting mass, you're asked to find the molar mass. And this is that particular case now, where you are given the mole and the mass, and you're asked to find the molar mass. So we have been given this, we're asked to find this. Now the relationship between them lies in the formula. So let's go on to solve. See, as I wrote down, 0.4 mole of the substance weighs 25.0 grams. And we know that the molar mass is the mass of 1 mole. So we'll then say, therefore, 1 mole of the substance weighs, we multiply this, that we have this is to this to what we don't know. So this times this divided by this one. That's what we're going to do. If 0.5 mole weighs this, that 0.4 mole, rather 0.4 mole is to 25 kilograms mole. 1 mole is to. So for us to obtain this side, all we need to do is so when we press this in the calculator, we obtain as 25 divided by 0.4 to give us 62.5 grams. Therefore, the molar mass is equals to 62.5 gram per mole. Okay, so we have number of moles equals to the reacting mass that will be equals to, we have the number of moles as 0.4, reacting mass 25, molar mass x, it's unknown. Therefore, we have x is equals to 25 over 0.4. For the x is equals to 62.5 gram per mole. So that's the solution to question 10. So let's quickly take question 11. To have question 11. So let me read the question. It says the mass of 800 centimeter cube of a gas X at standard temperature and pressure, that's STP, is 1.0 grams. What is the molar mass of X? And we have been given a hint that 1 mole of a gas occupies occupies at standard temperature and pressure 22.4 dm cube. So when we have this question, in our previous video on Avogadro, molar volume and mole, we solved the equation similar to this. So in this particular question, we will be repeating something almost similar to that one. And this is a question that involves mole and volume. And in this case, this is between mole and volume of a gas. So let me still split the paper. So this hint is very relevant. That's the molar volume of a gas at standard temperature and pressure. We have that 1 mole of a gas at standard temperature and pressure occupies 22.4 dm cube, which is equals to, we know that 1000 cm cube is equals to 1 dm cube. So this is equal to 22,400 centimeter cube, that's cm cube. So if 1 mole of a gas at STP occupies this, how many moles of a gas at that same standard temperature and pressure will occupy 800 centimeter cube? Yes, will occupy 800 centimeter cube. That means we have 1 is to 22.4. So x here being the unknown is to 800. Okay, so we're going to convert this to cm cube. That is why I wrote down this relationship here. Note, when the volume, the one is in dm cube and another in cm cube, it's very important that you leave the units of the volume in one measurement. If you are using dm cube, let every volume you are working with be in dm cube. Then if you are going to use centimeter cube, then let every volume you are working with be in centimeter cube. If you fail to do that, you discover you have errors in your calculation. So when we do that, we obtain the mole. We discover that x is equals to 800 over 22, that's 22,400, which is equals to, that's 0.036 moles. So let's go back to the question. The question is, the mass of 800 cm cube of a gas at STP is 1.0 grams. What is the molar mass? What is the molar mass of X? That is the gas. Now we know the molar mass is the mass of 1 mole of that substance. That is what the molar mass is. So if you look at this question, we'll discover that the mass of this mole we obtained has already been given to us. We obtain the mole from this volume and this hint. So that means 800 cm cube weighs 1 grams and the number of moles it contains is 0.036 moles. So we can put down to this and say, if 0.036 moles weighs 1 gram, 1 mole weighs, here that's the unknown, which I normally do label as my x. So this time around I'm going to solve from here to this side because of space. As you can see already, there's no more space. So when I put it this way, we'll have that 0.036, that's moles now, goes to 1 gram. Okay, that's equivalent to 1 gram. Then 1 mole, the equivalence we do not know. So when we put it this way, we'll have that x grams is equals to 1 mole times 1 gram all over 0.036 mole. Yeah, mole, we cancel mole, we have 1 over 0.036. So what we have is 1 over 0.036 gram, which is equal to equals to 27.78. You can choose to leave it this way, still approximate to 28 or 27.8. So looking at this, what this means is that the molar mass of this gas, that the molar mass of the gas X is equals to 27.78 grams per mole. And that is what we're asked to find. Now, I'll still try to bring up the method 2. In case I want to use the second method to solve this, there is a relationship as I showed us earlier on. If you go back to when I was deriving relationship between these things, I brought out this, that number of moles is equals to volume of gas all over 22.4 dm cube. And also, I modified it that reacting mass over molar mass, which corresponds to what moles is equal to volume of gas all over 22.4 dm cube. So here we are being asked to obtain the molar mass. We have been given the reacting mass as 1. The volume of the gas has been given as 800. Then we'll have this hint, this relationship, this as the hint. So if I want to use the second method, I will just write out the formula that reacting mass but in this case we know we need to convert this to cm cube since the volume given to us is in cm cube. So therefore we'll have that the reacting mass is, from the equation, the reacting mass is 1 gram. So we'll have 1 gram. The molar mass is unknown. Molar mass is equals to the volume of the gas is in centimeter cube, which is 800 cm cube. Then is either 22.4 dm cube or 22,400 cm cube. So when we put it down this way, make molar mass the subject of the formula. And when we do that, we're going to have the molar mass is equals to this 22,400 times 1 gram all over 800. So that's going to give us, that's 28. If you look close, you discover that this answer is close to this as well. Okay, the reason why this is this way is because we approximated at this point. Because of that approximation, this figure became low. So if you don't approximate, you might also get something that is exactly this way. So we're going to take question 12. Question 12 is still between a mole and the volume of a gas, if you can see. It says the volume of 2.5 moles of oxygen at standard temperature and pressure is, that we're asked to find it is, okay, so the hint here is that the molar volume of a gas at standard temperature and pressure is 22.4 dm cube. Now, solution. This means that 1 mole of a gas occupies 22.4 dm cube. 2.5 moles of oxygen, that's oxygen gas, will occupy, so that's 1 to 22.4, 2.5 is 2. Okay, that's the x. Now we have that the x is equals to 2.5 times 22.4, and that will give us 56 dm cube. So if I want to use the formula to solve this, you can still go back to one of those formulas I mentioned. You can rewind. There I say that number of moles is equals to volume of gas over 22.4 dm cube, which is the molar volume of a gas. So when we have it this way, we have been given the number of moles as 2.5. The volume is unknown. We're asked to find the volume. Then we'll have the molar volume as 22.4. Hence we'll have that the X is equals to 22.4 divided by 2.5. That's 22.4 multiplied by 2.5. And that is equals to 56 dm cube. So we're through with question 12. Now we're going to take the next question, that is question 13. Question 13 reads, what is the volume occupied by 2 moles of ammonia at standard temperature and pressure? What is the volume occupied by 2 moles of ammonia at standard temperature and pressure? So, owing to the fact that standard temperature and pressure was mentioned, by now from that molar volume, that relation, we know that 1 mole of a gas at standard temperature and pressure occupies 22.4 dm cube. Therefore, 2 moles will occupy, so have that this will give us as you can see, it's similar to the previous one we saw. Very similar to it, quite similar, almost the same thing. Look at it again. 2.5 moles was given. We're asked to obtain the volume. Here again we have the moles given and we're asked to obtain the volume. So that means this same question, yes, the same equation applies, as number of moles is equals to volume of gas all over the molar volume, which is 22.4. Number of moles is 2. Volume of gas is unknown. The molar volume is 22.4. Therefore, the volume of the gas is 2 times 22.4, which is equals to 44.8 km cube. Let's go to the next question. The next question is question 14. And here question 14 states that calculate the mass of chlorine gas which occupies a volume of 1.12 dm cube at standard temperature and pressure. And we're given the relative atomic masses of the elements. Here we have that chlorine is 35.5. Okay, yes, of the elements. And then we also have this hint that 1 mole of a gas occupies 22.4 dm cube at STP. It's as good as saying that the molar volume of a gas at STP is 22.4. Sorry. So we're asked to obtain what? The mass. This has been given. This given. This given. All these are hints. Volume given. Our main focus is to obtain what? The mass that occupies this given volume. And we'll come back to say 1 mole at STP will occupy what? 22.4 dm cube. So how many moles will occupy 1.12 dm cube? That will have that 1 flowing to 22.4 x, which is the unknown, flowing to 1.12. So when we want to obtain the x, we'll have that x is equals to now when we have this, we already have obtained moles. Then we know that there is a relationship between moles, mass, and the molar mass. And that is what we are going to go into now. And for this particular question, the method 2 is not here. I'm going to continue using the first method on this page. So we know that 1 mole of chlorine gas weighs 35.5. That is the molar mass. Therefore, 0.05 moles will weigh, we'll have the 1 from 35.5, 0.05 equivalent to, that's the unknown. So we'll have that the unknown, that's x is equals to 0.05. Is approximately 1 point. Now let's use the method 2 in solving this. If I want to use the method 2, I'll take note of what has been given, what I'm asked to find. Asked to find mass, I've been given volume, I've been given the molar volume, I've also been given what? The molar mass. So I'll take this one that says that reacting mass all over molar mass is equals to volume of gas all over molar volume. That's the 22.4. So the reacting mass is unknown. That would be my x. The molar mass has been given 5.5. It's equals to volume of gas has been given 1.12, and that is why we didn't convert, because it is already in dm cube. The molar volume 22.4. So we'll have that X is equals to, that will give us. So this is the mass of chlorine gas, which occupies a volume of 1.12 dm cube. So this is question 15. And question 15 is a nice question. It says 14.8 grams of a salt Z dissolved in 250 cm cube of distilled water gives a concentration of 0.08 mole per dm cube. Calculate the molar mass of the substance. Calculate the molar mass of the substance. When I was introducing this, I said we are going to solve some exercises that is going to deal with molarity, because mole has a relationship with volume. So if we are considering a gas, we deal with molar volume. Now, but the relationship between moles of a substance and then volume for a liquid, you see that being spelled out when we are considering topics like molarity and solubility. So I gave this formula then, that molarity is equal to moles of solute all over volume in dm cube. And then also I say that mass of solute all over molar mass times 1000 cm cube of solvent over volume of solvent is equals to molarity. At that point, I mentioned that this is because of the need to convert volume to dm cube. Then I also continued with this one, that's molarity is equals to mass concentration over molar mass, and then the mass concentration is equals to mass in grams all over volume in dm cube. So I gave the relationship then because that is what we need in order to solve questions like this. So how do we go about solving this question? So when I want to use the first method to solve this question, what am I going to do? Now, here's what I'm going to do. Let me split my paper. This statement is from this place actually. 14.8 grams of a salt dissolved in 250 cm cube of distilled water. That means that this 250 cm cube of the distilled water contains 14.8 grams of the salt. That is what it implies. Now we know that from here I say that 1000 cm cube is equals to 1 dm cube. And the unit of molarity or molar concentration or solubility is a mole per dm cube. When we do the next video on that, we are going to understand molarity and solubility better. Let me just give these explanations now. So if 250 cm cube contains 14.8 grams, then therefore 1000 cm cube will contain, or what this means is 1 dm cube will contain, now we know how we do this work here. I usually say 250 equivalent to 14.8. 1000 is equivalent to the unknown. So here we have that the unknown x is equals to 1000 times 14.8 all over 250. That will give us 1000 times 14.8 per dm cube. Because by doing this, we have converted this volume to dm cube. That's from cm cube to dm cube. And then we'll have grams. So what we'll have here actually is 59.2 gram per dm cube. And this is called the mass concentration. Just take note of it. This is known as what? Mass concentration. Mass concentration. That's mass in grams all over volume in dm cube will give you what? The mass concentration. Now the next thing I'm going to do is then to put this then into this relationship. There's a particular relationship between mass concentration and molar concentration and the rest of them. That is what I'm going to use now. We know that molarity is equals to mass concentration all over molar mass. So the molarity or the molar concentration has been given as 0.08. That's molar concentration, molarity or molar concentration. So we have 0.08 is equals to, and here the mass concentration, we obtain that as 59.2 all over molar mass. So we have that the molar mass is equals to 59.2 all over 0.08. When we compute this, we are going to obtain 59.2 divided by 0.08. That is that 740 gram. Okay, 740 gram per mole rather. Now we just use the relationship, although we entered into formulas. But then in case we want to use the one I called method 2, that's a case where you use just formulas to solve immediately. What are we going to do in this particular case? Now note we have been given the mass of solute. We're asked to obtain the molar mass. We've also been given the volume, and not just the volume, also we have been given the volume. So if we convert the volume and also we are given the molar concentration, we can be able to obtain a very fast answer, and that is what this formula is all about. So how do I go about solving it? Let me come to this question here. I'll just put down that mass of solute all over molar mass as volume of solvent cm cube is equals to molarity or molar concentration. So here we have the mass of solute as 14.8. So we'll put 14.8 here. The molar mass is unknown. We don't know what it is. 1000 is given. Now the volume of this is what? 250. So here we'll put 250 is equals to, what is my molar concentration? 0.08. So here I have 0.08. So if I go on to solve, I'll have 14.8 over x times. So 1000 over 250, that's 4. So 4 is equals to 0.08. And that is going to give me 14.8 times 4. 9.2 is equals to 0.08. Therefore, we'll have that x, which is equals to molar mass, is equals to 59.2 divided by 0.08. That is equals to 59.2 What this means is that the molar mass of this salt that was dissolved in 250 cm cube of distilled water is actually 740 gram per mole, if it gives us a concentration of 0.08 mole per dm cube. At this point, we've come to the end of today's class, and this is from Texel Academy. And if you followed us so far up to this point, it's very necessary that you subscribe to our channel for updates. And once you've subscribed, not just subscribe, you can also like our videos. In addition to liking our videos, you can share to your friends. So support us by subscribing, liking our videos, sharing to your friends. Thank you.